Hi, this is Kyle Rowley and Jeff Sadler from BYU Geoinformatics class. We've created a program called Trail Map. The purpose of our program is to map trails and to calculate from a map the distance, elevation, slope, and other computations that would be useful to a runner or a cyclist or anyone that's out along a trail to see what they're up against and see what trail they have. To begin with, we're going to show off the program, how it works. I'm going to bring in a base map. So we're going to bring in the Google Terrain base map. When the program loads, by default it loads to a location in Utah. We have a DEM already loaded for that area. The user is able to load a DEM for anywhere and go to different locations to get elevations and map trails. So we're going to show off what the program can do. We're going to zoom in and load a trail that we've already mapped, the trail to the top of Timpanogos. We brought in Google Map. Let's go to Terrain. And so by clicking on this button, we can load a trail. And we have the Timp trail. When the trail is loaded, it's a shape file, and it follows the trail, and which corresponds to the elevation here in this Z graph. We can also draw a trail, and so we're going to zoom in and draw the trail to Stewart Falls. And you can digitize the trail. A red line appears following the cursor. By selecting once, a point will be drawn on the map, and a double click will end the line like this. When you're done digitizing, you can save the file as a shape file. So we'll call this Stewart Falls. And save. And the Stewart Falls line then appears on the Z graph. Clicking on this button will bring a pop-out where you can see a little bit more detail of the Z graph and compare the two lines. On the right, we have a list of statistics, and you'll notice the Timp trail here is selected. Down in this selection box, we can change that to the Stewart Falls trail. For each trail, the distance is listed with units as changeable. You can select this box to double the distance, showing that you went out and back, that you returned from your destination. Show the max elevation, the gain, the maximum gradient as a percentage, and then we have an algorithm that computes the difficulty of this trail so the trails can be compared against each other. The Timp trail is a difficult trail, steep and long. Stewart Falls is shorter and listed as a moderate trail. Here we have a pace calculator so that you can put in the amount of time that you took to go on the trail, calculate the pace. So if you took 1 hour to go 2.1 miles, your pace would be 28 minutes per mile.
So, hey everybody, I'm going to show you how all this works under the hood. So we're just going to exit out of these and show you the code. So the first form is the form which the map is on. I'm just going to go over the basics and highlight a few things that may be unique to our version of a hiking trail map. The first thing I'll highlight, well, this is declaring all the variables. Everyone does that. It's pretty basic. This part is kind of unique. It has to do with the base map. You have to bring in this kind of shell thing, and I'm not sure I quite understand it completely myself, but that's what's important, or that's what's necessary to bring in the base map, as well as some other things. One of the challenges we had in our project was dealing with slope. We originally attempted to calculate the slope on just the line by the good old rise over run and trying to figure out the maximum slope, etc. for that, but we weren't really confident in our results, so we decided to calculate a slope raster on our raster, and this happens right here. Now the problem with that became, it just took a lot longer for the program to load when we started it up, and so we had to use a coarser DEM for it to load in a timely manner, and that's something that definitely could use some improvement, and we could try to find a better solution if we had more time, is getting the slope. The basic flow of our program is that the user inputs coordinates either when drawing or inputs it when loading a shapefile, and then those coordinates are put into a list, and the list is passed to a function which plots them on the Z-graph and also calculates the different statistics which are shown on the other form. So this is an example of what happens when you are drawing the map or drawing a line. The coordinates are here, like p.x is the x coordinate, p.y is the y coordinate, and those are saved to a list. Maybe one of the more unique features of what we did is this right here. This section is where we decide on which color to make the line. We decided to make an integer called color counter, which was incremented each time the plot points function was called. And according to what value the color counter was in this function, a different color is assigned to the curve that is plotted. So, for example, the first time this function is called, the color of the line on the plot is blue. The next time it's red, and I think we saw that earlier with Kyle. And then if you were to do a third time, it'd be green, and then fourth plum, and then it would start over. This was a nice feature that allowed the elevation plots to be more differential, one trail to the other. A third, or a second thing that we wanted to highlight was this function that is called when we click to pop out the Z-graph to see a more detailed view. And when this is called, this form, this form passes several parameters to the other form, including a graph names list, name list, dist list, etc. So what happens is when we calculate the distance or the minimum elevation, maximum elevation, etc., these values are put into lists, and the lists, each of the lists are sent to the other form where we can display the numbers, and according to which of the list box curves is selected, the different the corresponding statistics are shown, and Kyle's going to go over that a little bit more. But I think that's pretty much it for this form. Just one last comment is there are actually two lists, so each time the plot points function is called, the list is populated again, so there is redundancy in that, but the way that we deal with that is we also pass a graph name list, which is a list of all the curves on the graph once that at the time that the pop out button is clicked. So that way the user the program knows only to really care about the ones that are on the graph instead of ones that may have been put on there previously. I'm going to pass it back over to Kyle, and he's going to explain more about that pop-up window.
So the pop-out window that Jeff's talking about, the Z-graph window, here in Form 2, one of the things we wanted to highlight from this form was the box that's in the lower right-hand corner where we can select the different curves and have the information come out. Right here is where we have the list of each of the trails. And for that reason, we pass in a list of each elevation of the max, min, the gain, the slope for each location, so that when we select that in the selection box, that information then populates the labels and appears. Right here we have a way, this is the way that we are rating each trail based off the distance, the gain, and the slope. And so as the distance gets greater, the difficulty level rises by 1. The same is true with elevation and slope. And then those values are brought into this if statement, which will determine the level of difficulty for that trail. We also, here's where we have the labels displayed for the summary text, and we have the options to change things from different units, as is shown here. Down here is where we have the pace calculator and the methods we've used to gather information from the user input to make calculations based on the distance and to output the pace. We hope you've enjoyed watching this and find our program useful if you ever use it.
Thank you.